Hello everyone, welcome to data structures tutorial. In previous session we talked about stack. We have seen definition of stack. We also talked about what operations we can perform on stack such as isfull, isempty, peek, push and pop. In previous session itself we have seen how to define the functions as isempty, isfull and peek. In this session we will talk about how to define the functions that is push and pop. So let's begin. Now the most important, push operation. Now I have to perform push operation. Tell me what I should check, is empty or is full? Is full, right? So the process of putting new data element onto the stack is known as push operation. Push operation involves a series of steps. What series of steps we have? See here, step 1, check if stack is full. We can say this is the algorithm for push operation. So check if stack is full. If stack is full, produce the error and exit. What kind of error? We will give the message as stack overflows or stack is full. That is the error message. That is what we are going to produce. Okay, and then we will stop the program. If stack is not full, then increment the current value of the top to point to the next empty slot or space, and then accept a new input or data element to add onto the stack and put that element onto the stack location where top is currently pointing. So if currently top is pointing 3, that means I have one element at location 3. We will increase the value of 3 by 1, so it is going to become 4. New element will be accepted and that element will be placed at that location, that is location number 4. When we have to insert one more element, then we will increase the value by 1 and then we will place that value at that location. Now when we are using array implementation, the stack size is fixed. In that case, if the size of my array is only 5, so index will go from 0 to 4. So when we are increasing index by 1, that means when we are making index 5, in that case we will get a message as stack full. We should get a message as stack full. That is the push operation. Is this clear to everyone? Okay, so once we have added element onto the stack, we will return as element is added onto the stack, or element is pushed onto the stack, or element is inserted into the stack. Is push operation clear everyone? Okay, now it's algorithm, very simple. Push stack data. If stack is full, return null. That means we have to give a error message. So if this is not true, then increase the value of top by top plus 1. This symbol is called as assignment. So increase the value of top by 1, assign it to the top, and then whatever new element we have accepted, save that element on the stack top location. So whatever stack top location we have, new element will be placed on that particular index value. Is this clear? Same can be written in C programming like this. Wide push. Now why I am placing here wide? Because we are inserting element into the stack. So it is not going to return anything, because it is accepting the value and placing it onto the stack. So we will check is full. So when is full, now see here I have written exclamation mark. So what it means? Not. Its meaning is not. So if not is full, that means whatever is full is going to return opposite of that, right? So top equal to, increase the value of top by 1, and then stack of top is equal to data. That means whatever data we want to let's say insert into the stack, that is what we are accepting and we are placing it onto the top of the stack. And if it's full, that means is full returns true. Okay, so what is going to happen in that case? Could not insert data, stack is full, because my stack is full. Is this clear? Is this clear to everyone? Okay, what is going to happen? Fine. Now let's talk about the pop operation. I hope you have understood is full, is empty, peek and push operation. Now we are going to talk pop operation. Purpose, I hope everyone understood. What is the purpose? Very simple. Accessing the content while removing it from the stack or removing element from the stack is known as pop operation. It removes lastly added or last in element from the stack. It removes last in element from the stack. In an array implementation, listen carefully, we are implementing here stack with the concept of array. So in an array implementation, the pop operation, the data element is not actually removed. Data element is not actually removed. Array element is not actually removed. What actually do? Instead, the top is decremented to lower position. So in case of array implementation, when actually I will show you the implementation, I will show you that array element is not actually removed. What we do, we are decrementing the value of or incrementing the value of top pointer by 1. So in case of removal, we are decrementing the value of top by 1. That is what we are doing. But in case of linked list implementations, but if we do linked list implementation, in that case pop actually removes the data element and deallocate memory space. Remove the element and deallocate the memory space. Now let's see the pop operation. What the steps are or algorithms are. Very simple. Check if stack is empty, because we want to perform pop. So if stack is empty, produce an error message, that is stack is empty. Alright. If stack is not empty, you can remove the element from the stack. But from what end? Top end of the stack. So if stack is not empty, that means we have some elements into the stack. So access the last data element which is at the top of the stack and then remove that element by decreasing the value of top by 1. This particular algorithm is for implementing the stack by using array. Right? So in case of array, we have to decrement the value of top by 1. In case of stack, in case of let's say linked list representation also, we decrease the value of top by 1. In case of array, actual element is not deleted. In case of linked list, actual element is deleted. Now return success, and finally the algorithm for pop operation. Very simple. If stack is empty, then return null, because my stack is empty, I cannot remove the element from the stack. Then whatever top position we have in the stack, so assuming that currently top is pointing to 4, so 4 is the index and actual element is for example 10. So stack top 4, index 4 is used into the array and that value is actually 10. So 10 is saved onto the stack and we give message as the data 10 is removed from the stack. Now when this data is removed, my stack should point to the next or let's say previous element of the current element. So top will be decremented by 1 and now top is going to contain value as 3. So that is what is done here. Top is equal to top minus 1. So here the top value will be decremented by 1 and then we are returning which element is removed from the stack. In our example it is 10. Is this clear? Same code is written in C is like this. If is empty, so whatever is the opposite of is empty, that is what taken. You will understand this when actually we will write the code. What we have to write? Remove the top data from the stack. So here in this example 10, as I am showing you, okay, then top is decremented by 1, so from 4 it becomes 3. Then we are returning data value, that is 10, and it will be printed. However, if my stack is empty, then in that case it should display the message as could not retrieve as stack is empty. Is this clear to everyone? Okay. Now we have seen all 5 operations and now we are going to see all these 5 operations with animation. So assuming that this is my, I hope you can see the cursor that I am using. This is my empty stack with size 5, n is equal to 5. So the size of my stack is 5. That means I can store 5 elements in my stack. Currently the value of top is minus 1. Why I am taking the value of top as minus 1? Because I am doing implementation with array. Array index starts with 0. So to represent my stack is empty, I am initializing the value of top with minus 1. Now as the value of top is minus 1, stack is empty, right? Now I want to perform push operation 1. So when I am pushing item 1, top will be increased by 1 and now the value of top is going to become 0. So at index 0, element 1 is inserted into the stack. Is this clear? I want to perform one more operation, that is push 2. Top will be increased by 1. It is going to become 1. So at index 1 we will have element 2. Then push 3. So again top will be increased by 1. It is going to become 2. And at index 2 we are going to insert element, that is 3. Same with 4 and same with 5. But what is the index of the element 5? 4. Now whether any place available in my stack? No, because the stack size is 5. 5 elements are inserted into the stack. So here now we will check whether top is equal to n minus 1. Now tell me, what is current value of top? 4. What is the value of n minus 1? 5 minus 1? 4. So when top is equal to n minus 1, it means that stack is overflow. Is this clear? Okay. Now I want to perform pop operation. Push operation we have seen. Now I want to perform pop operation. What are the current values of the top? 4, right? And currently we have seen top equal to n minus 1. Okay. Stack is overflow. Now n is equal to 5. That is what we have seen. Current value of top is 4. When we are performing pop operation, it will remove the element 5 from the stack and top value will be decremented by 1. So 5 is removed and top is decremented by 3. So currently top is pointing to element 4 whose index is 3. When I am performing one more pop operation, it is going to remove 4 and top will be decremented by 1. Again I am performing pop operation, it is going to remove element 3 and decreasing the value of top by 1. Again one more pop operation, remove 2 and decrease the value of top by 1. Again one more last pop operation, remove element 1 and now the current value of top is equal to minus 1. When at this time I am performing one more time what? Pop operation, it will check that the top value is minus 1. It will display message as stack is underflow or stack is empty. Is this clear? All operations, how the push and pop operations and how we are checking the stack empty and stack overflow conditions? Yes? Fine. Now we are going to implement stack using array, which makes it a fixed size stack implementation. Now we are going to start actual implementation.